Hello, everyone. Welcome to our class today. This class is a part of GRAITEC BeamUp Global Digital Conference. So our topic today is going to be how to apply notional loads in advanced design based on North American codes. So let's go forward with our slides. So the outline of the class will be, we will have a short introduction on GRAITEC Advanced Design Software. So we will go through some of the features, modeling, etc., etc. We will see how you can simply create your geometry in advanced design. Then I'm going to show you how you can apply notional loads in advanced design, which are required for some specific structures, steel structure, etc., with from different standards for North America notional loads to include the lateral sway of the structure in your internal forces and design. Then we will check for the results, and at the end we will have a question and answer session that you can use the chat tool to type in your questions, and I'm here to answer all of your questions. So let's jump into the live demo inside Advanced Design to see all of those features and as well the notional load. Okay, we are in Advanced Design, the first page of the software. So to just give you an introduction of what we have here and how to start a project, first of all, you can always create a new project from here. You can open recent projects. We have a very important beam import tool as well here. So we have a specific format which is called GTCX. So you can actually import or export your models from other softwares, let's say from Revit or Advanced Steel. So it will import automatically your geometry, sections, material, etc., etc. And here also we need to define our configuration. So in this case, as you see, like I have defined Canada, then we have the language, and here you see all of the design codes that we have in advanced design. So as you see, I can just drop this down and I can even change the design codes for either load combinations or seismic loading. We have automatic climatic load generators in advanced design. So to create loads like wind, snow, or seismic automatically, you can use advanced design. Then we have the reinforced concrete design standard that you can select from here. As you see, we have several codes, international codes, and as well North American codes. And finally, we have the steel and timber. So in case if you want to change the localization, it's always here. So you can go on and, for example, for Canada or United States, we have the default localization. So as soon as you're done from here, you click OK. And to start a new project, we can click on New. By the way, in case if you want to check some of the sample projects in Advanced Design, you can use these sample projects from here. As well, here we have a learning tool that if you click there, you can access some tutorials, webinars, videos, etc., to get you started to use Advanced Design. So here I will just create a new project. So we click on New. Okay, so as you see, the new project is created. So in case if you want to assign some names or addresses or some specific parameters for your project, you can assign them from here. So I will cancel this for now and close the tips. Okay, so this is the general GUI of advanced design. So everything has been organized like nice and clean. So for example, here on the left side, I have my project browser. So any type of structural element or loads, etc., that I'm adding to my model here, it's going to be listed in my project browser here, and it's going to make it much more easier to access those elements, hide them, display them, isolate them, etc., etc. So we will see that very shortly. The top panel that I have here, it contains several tabs. So I have the Home tab, we have the Objects, Utilities, Analysis. Then we can check the results from here. In case we have reports or documentation, we can access them from here or modify them. We have the Beam tab there. So this is all of the tools related to transfer of the model or BIM workflow. In case if you want to import, export, synchronize your models in advanced design with other software, you can use this tab here. We have Manage tab to define some specific parameters, project configurations, uh, customize cross sections, defining new sections using the section calculator, etc., etc. And as well at the end, we have the design modules, which is going to be used for example, if you want to detail your elements, especially concrete elements in advanced design, like put rebars, do calculations, even see the drawings, bar schedules, etc., etc. We have all of those tools as well here in advanced design in the design modules. So I will go back to the home tab. So this is the main tab to create your structure or manage it. So we have different types of filters, views, render modes, etc., etc. To add a member in advanced design, it's very actually simple. So you don't need to have points or nodes or other elements. So you just click on a linear element. And now I can see all of the properties of that linear element here. So you can start from concrete, or the material is here. I can just simply click there, drop down. I can select one of the default materials that I have here, or if I cannot find them here, I can easily click here and access the full library of material that we have in advanced design. So I can click here, library. So we can go, for example, as steel, and we can select our North American code. For example, in this case, we can go with CSA. And as you see, we have all of the standard material uh, from CSA. So you can assign them and add them to your project there. So in this case, I will just use, for example, one of these Canadian materials. So let's go with 350, for example, here as the material of my section. Same thing for the section or profiles. So here I have some default ones here already saved on my hard drive to open when I'm opening my project. Or if I want to add more, I can click here to access the library of materials. So we can go here and we can go to non-compound. And here I have the full library of sections either for North America or any other place, like international codes sections for other countries. So in this case, for example, we can go with CISC. Let's go W section. And now I can select my section from here. So in this case, I can just click here, for example, this section, and I can click OK. So you see it's going to be selected. So now I have assigned my section as well. There are also other properties that we can modify, but now I'm just going to be adding my members there. So for example, it's just using the grid lines. You can add actually grid lines as well, the snap points, but it works with the snap points. You have control on all of the snap points and as well, etc. in advanced design. So in this case, just to keep it simple, I will just click here and start to add my members. So for example, my grid is like 5 meters by 5 meters now. So we can go, for example, here, like 3, 3, and 3. So now I have my 2D frame created, each for in 3 meters. And as you see, we have tooltips in advanced design that when you put your mouse on the elements, it's going to show you the coordinates, etc., etc. So this is like a simple frame. Again, as I mentioned earlier, if you want to modify your sections, you click on that. So for example, if you want to add releases, initial constraints, change the mesh, even if you want to define design, still design criterias, like lateral torsional buckling, lateral supports, etc., etc. We have all of those options here for steel design. So I can easily change this 2D frame to a 3D frame, or I can also work on this 2D work plane. So for example, if I want to add another span, you just select those, and I will just use the ADs tool to easily copy my section. So as you see, now I have a 2D frame. I'm working on a 2D plane. Changing the planes or work planes is also very easy. For example, if I want to go to top view, I can use Alt 3 to go to top view. So XY, and just click on new work plane, and now I will have my work plane as an XY direction And now I can actually turn this structure for a 3D structure. And it's going to be very simple. You just select the elements, hold control, and now I can, you see, change the structure as a 3D. So let's go with this. And now I have 2 frames like that. And again, now I have snap points for all of those points. So you can just click here and start just adding your members, very easy, using those snap points. So there you go. As you see, I have my 3D structure. Again, copying is very simple. As soon as you have your snap points, you go there. And now I can actually make this as a second story um, for my structure. Or same thing here, like if I want to add another span there, you can just click here, select here, and I can just move it to have another span here. Okay, there you go. So everything is going to be taken care by AD. So all of the connections, nodes, etc., will be automatically meshed by AD. So in case if you want to also add some supports to this structure, again, we have the tool here. So we have different types of supports. We have point, we have linear, and also we have planar supports in AD. So I can simply go click there, and now I have my support as foundation. We can have different types of support. So we can have a fixed support, we can have pin, and we can have also other types of supports that you can actually modify all of the degrees of freedom for that specific support. I will, in this case, I will stay with fixed. And now you can just simply click and you are adding the supports to the bottom of the columns. So very simple. There you go. So I have my supports on this structure. So as I mentioned earlier, all of these elements are going to be listed here in my structure tab. So now I have all of the linear elements, all of the supports that I have here. I can select them, hide them here. We also have like other tools here. Like I can have different systems here to organize my model better. For example, if I want to group all of my first story columns in one system here, you can just simply go here, create a new system, which is F6. And I can name this like a first floor. And now I just need to select my columns, very easy, and drag and drop them here. So just go there, drag and drop them in my system here. There you go. So now I have all of my columns in that system. Now I can manage them separately. For example, if I want to hide them, you just click here and it's hidden, and I can bring them back from there. So on top of that, we can also add floor elements or slabs to this structure. Again, I have this tool here, very simple. You click there, you select material, thickness, etc. And after that, just by clicking on the snap points, I can add the floors. There you go. And as well for the first story floor, there you go. I have my floors. So AD again will take care of all of the mesh nodes, etc., connection between the slab and the members automatically. In terms of what kind of loads you can apply, for example, we have all of them here. So just go there, right click, and I can create a case family. So for example, I can create a dead load, click there. Dead load case will be created, and it automatically will contain your self weight. And as on top of that, I can create other loads. For example, I can create a live load. So same thing here, a live load family. There you go. And for example, if I want to add a uniform load on the second floor as live load, just click there. And here we have different types of loads. So in this case, I will go to planar load. I put my intensity of force here. So for example, we can put -5 kilonewton. And now you just using the snap points, you can add very simply your live load to that floor. Okay, so very simple. So since the subject of our webinar today is actually notional loads, so how we can apply our notional loads automatically to this structure. So we have several ways of creating those loads in advanced design. The first way is obviously you can go to our objects here, and here you will find the notional loads. So I can click here and automatically I can create my notional loads. That's one way of doing it. The other one is you can also control the notional loads on family type. So on which family type of loads you want to create your notional loads. So for example, if I want to create them on dead loads, click there and right click, and I have automatically here create notional loads on that specific load case. So you click there. So now I will just assign the name of the load case that I have here. So load case number 1. So you have the coefficient, which in this case I'm using 0.005, the coefficient of the notional loads to the vertical loads. And here also I can decide on which direction I want to apply my notional loads. So x plus, x minus, so we can go actually in all directions around the structure. So all of the lateral sway of the structure will be covered here. And as well here we can decide on which load case family I want to add those notional loads. So for example, for dead loads, I can use dead loads. I will keep it like that and click apply. And if I close this, you will see that the notional loads has been automatically created for this structure on my dead load case. Same thing for the live load case. So for example, I can go here, click that, right click, notional loads, and now I can create it based on the second load case, same value. In this case, also, I'm going to select all of them. And this one, for example, we can assign it to live loads. And click apply. So you have control on all of those load cases and created notional loads. So, and as you see here, I have the notional loads created. I can actually check them to see how much is the intensity. You can, even if you want to modify, you can modify them. So you have control on all of the load cases from here as well. Okay, so the next step here will be creating load combinations to perform my analysis. So I will just go there, right click, and now I have options here. So I can either add the load combinations manually using this, or I can use the automatic combination generator in AD. So click there, I will click generate, and AD will automatically create all of the possible load combinations, considering also the notional loads there, and click OK. So now that I have defined my notional loads on my structure, I can actually run analysis. And let's say in this case, we just do an FE calculation just to investigate the results and click OK. Now the calculation will be started automatically. AD will automatically mesh all of the elements and perform the finite element analysis. And actually our analysis is just done here. And now I can access the results. So for example, for displacement, click there and there you go. This is the displacement of my structure and you see the value there. You can switch based on all of the load cases and load combinations that you have here. So I have all of them here, so I can investigate all of the deformations based on either load case or even notional loads. So for example, I can go and check my first load combination, this one, and this is going to be one of those load combination which also includes the notional loads on my structure. So as well, the other option that we have here is on top of the displacements, I can also check for internal forces. So click there, and here I will select the type of internal force that I want to display here. So for example, if you want to go to axial, click there, click here, and there you go. This is the axial force in my columns or elements, as you see here, and you see the intensity there. Obviously, I can modify the size of the diagram using this bar here. And as well, I can also display the values on my structure. So you can also control on the values or font size here. So you can make it larger or smaller from here. As well, we have also other tools to check the results. So let me just get rid of that. Okay, great. In case if you want to check also other type of results, for example, if I want to just investigate this column, I can select that column and I can go here, result curves, and now I can see the moment and actual force on that column here based on all of the combinations that I have here. So actually I'm seeing now the forces, and for example, if you go to actual, I click here, and now I will see the maximum actual load that it's coming from different or all of the load combinations that I have in this structure. Obviously, we have also control on that, and here I see the moment. So you can click here, and here I can decide what kind of results I want to see. For example, which load cases or load combinations. Actually, now we are showing all of them, but you can go and select just one of them, the one that you want to investigate. Also, you have the option to define envelopes. So if I want to check for envelope results of all of the combinations, I have an envelope tool in advanced design that we can decide which type of force envelope I want to see um, in my structure. We can also do a code check or steel design check on this structure. So for that, we can just go back to our model. And now we can actually run a steel design on the same structure. So we go to analysis, and we will perform a steel calculation on the same structure and click OK. So now AD also as well verify our steel sections based on the design code that we have selected, which was CSA 16. Okay, now we also have the steel design results. So now, as you see on top of all of the finite element results that we already discussed about it, now we can also check the steel design. So for example, here, I can go to strengths, and we can either go and check the work ratios one by one based on each internal force, or we can go to max and click here, and there you go. These are the results of the steel verification for my structure. So as you see here, we see the percentages there. On top of that, if we want to go more into detail, for example, I can select this section and we can click here to see the exact results of the steel design code check. So here we have the cross-section properties. In case if we have defined the deformation criteria, AD also will check for those. And here we see all of the code checks based on each class of S16 that we have here. It's mentioned there. We have all of the internal force and resistance values for tension, shear, bending, and also combined. So we can even generate a report of that. So I can click here. And now we see the full report of steel design for that specific section. The other nice tool of ADs also is optimization. So in case if, for example, if you want to optimize a section, for example, to use a more economized section, we can ask AD to do that for us. So for example, here, if I check this this beam here, we will see that its workload ratio is 13%. So what I can do in AD is I can actually ask AD to provide me with cross sections, which is going to be more economized. So we can have end up having cross sections that they have higher workload ratio, and we are actually economizing our structure. So for that, simply we go to analysis and steel design, and in the settings, we have the option of optimization here. So as you see here, we already have a check mark. So any kind of element or section that is going to be over 100% workload ratio, AD will warn us and it will provide us with a section. And in this case, I will activate also lower than 50%. So in this case, now if AD sees a section lower than 50%, it will again provide us with more economical sections. So we also have some sort criteria, so we can sort the sections that AD is gonna offer based on height, inertia, or etc. So in this case, for example, we can go by weight and click OK. So for example, if I go back to this section or member again, and if I perform the steel calculation again, we will just work on this section for now. So yes, and again, we check it, it's 12%. But let's see if AD is able to provide us with other sections. So for that, we select the section and we click here on this icon there. And as you see here, AD is proposing other section that it's going to be more economical. So it's going to be 62% of workload ratio for us. So this is also how the structure optimization works in AD. So it depends on the user. So if you want to accept this change, we can just click here and accept this and click OK. And AD will automatically change that section for us. So now if I go back to my original model, we will see that this section, it's been changed for the other section. So this is also how structural design and structure optimization works in AD. Okay, this concludes our class today. So I hope you have enjoyed the class and all of the topics that we talked about them. So thanks again for your time. If you need more information or even if you want to have a trial of